Hello, my name is Ashley Goodnight, and this is my Week 8 reading review for Physics 2212. This week, all of the EDX videos related to the larger concept of electrical circuits. We were introduced to three main ideas: resistance, circuit design, and capacitance. But first, let's give an overview of information provided in the introduction. In the beginning of this week's lecture videos, we learned a couple of important concepts. First, we learned about the node rule, which covers conservation of charge. Next, we learned the term EMF, which is the input energy per unit charge from non-electrical processes. The final point was the loop rule, which states that the sum of delta V in a circuit is zero. Next, we moved on to the topic of resistance. Most circuits aren't just made of wires and a battery, so we introduced the idea of lumped element circuit models. Using the diagram and applying loop rule, we see this expression for delta V. Also in this video, we learned about the constant variable U, which represents the mobility of a specific material. This constant can be used to derive Ohm's law, which gives us this explicit equation for resistance using sigma, the conductivity variable. Here is a basic diagram representing a series circuit. When we apply loop rule and node rule, we discover the following properties. Let's compare these results to a parallel circuit. Here we can see another diagram representing a basic parallel circuit. Again, once we apply loop rule and node rule, we yield the following information. Now moving on to capacitance, we looked at an example of a parallel plate capacitor. Depicted by the diagram, we derived an expression for the delta Vc, which can be used to find a value C for capacitance, which has units coulombs per volt, also known as farads. We continued this discussion of capacitance by taking a closer look at RC circuits that, guess what, involve a resistor and a capacitor. We find that the delta Vc value changes over time. Using these expressions, we can solve for overall functions for the current and charge over time. This week's lessons apply directly to my major, electrical engineering. At Georgia Tech, EE majors select fields or threads to specialize in. Two in specific: telecommunications and circuit technology have required courses that build off what we're learning in this class. Those who follow telecommunications take ECE 4350, electromagnetic and microwave applications, while students studying circuit technology take ECE 4391, electromagnetic compatibility. That wraps up my introduction to Week 8. Thank you for listening.